Have you ever looked up at a mountain and seen a little cabin gliding silently through the air? Or maybe you've ridden a charming, clanging car up a steep city street? If so, you've witnessed the magic of a cable car. These amazing machines are a form of transportation, a way to get from one place to another. But they're not like cars or buses that run on roads. Instead, they use a system of strong steel ropes, or cables, to move. It's a beautifully simple idea that solves a very big problem. How do we travel up and down very steep places where building a road would be difficult, expensive, or just plain impossible? In bustling cities with giant hills like San Francisco, they help residents and tourists get around without having to climb those exhausting slopes. In snowy mountain resorts, they whisk skiers and snowboarders to the top of the peaks in minutes, giving them more time to enjoy the ride down. They also offer breathtaking views that you just can't get from the ground. It's like having a window seat on the world. So, what is a cable car at its core? Think of it as a passenger cabin that grabs onto a moving rope. That's the basic principle. The cabin doesn't have its own engine. All the power is located somewhere else, usually in a big station at the top or bottom of the line. The car is just a passenger, hitching a ride on a constantly moving loop of steel. At the heart of any cable car system is, you guessed it, the cable. But it's not just one single rope. There are often different types of cables doing different jobs. The most important one is the haul rope or traction cable. This is the cable that actually moves. It's a continuous loop of incredibly strong, twisted steel wire that runs from a main station, up the mountain, around a big wheel at the other end, and all the way back. A powerful motor in the station is constantly turning this loop like a giant conveyor belt in the sky. Now, how does the car connect to this moving cable? This is where a very clever device called a grip comes into play. The grip is like a mechanical hand attached to the bottom of the cable car. When the operator wants the car to move, they use a lever to make the grip clamp down firmly onto the moving haul rope. Voila! The car is instantly pulled along at the same speed as the cable. In some larger systems, especially those that go high up into the air, there's a second type of cable called a track rope or support cable. This cable doesn't move at all. It's a thick, heavy steel rope that is stretched tightly between towers, acting like a stationary track or a rail in the sky. The car has wheels on top that roll along this fixed track rope, which provides all the support. The separate, smaller haul rope is only used for pulling the car along. Not all cable cars are created equal. There are several different types, each designed for a specific purpose. One of the most impressive is the aerial tramway. These usually feature two large cabins that operate in tandem. As one cabin goes up, the other comes down on a parallel set of cables. They are connected by the same haul rope, so the weight of the descending car helps to pull the ascending car up. Trams often travel long distances between just two stations, soaring high over deep valleys or rugged terrain. Then we have the gondola lift, which you've probably seen at ski resorts. Instead of two big cabins, a gondola system has many smaller cabins, maybe seating 4 to 12 people each. These cabins are attached to a continuously moving cable. As a cabin enters the station, it detaches from the main cable and slows down, allowing people to get on and off safely. Then it accelerates back up to speed and reattaches to continue its journey. Finally, let's not forget the funicular railway. These are the cable cars that aren't flying through the air, but are instead climbing up a hill on a railway track. Like an aerial tram, a funicular typically has two cars attached to opposite ends of the same cable. The cars counterbalance each other. As one goes up the slope, the other comes down. You'll find these charming systems in hilly cities around the world, providing a vital link for communities built on steep inclines. So, where does the go in a cable car come from? Well, it all starts in the engine room, or what's often called the drive station. Inside, there's a really large electric motor, but the motor isn't in the car itself. It's anchored right to the ground. The main job of this motor is to turn a giant wheel known as the drive bull wheel. The haul rope is wrapped tightly around this massive wheel. So when the motor spins the bull wheel pulls the entire loop of cable, moving every car that's attached to it. It's kind of like turning the crank on a giant fishing reel to pull in the line. But motors don't work alone, especially when you're lifting heavy things up a mountain. This is where a fantastic physics concept comes into play: the counterweight. In systems like aerial trams and funiculars, there are actually two cars operating together as a team. Both are attached to the same cable loop. As one car goes up the mountain, the other car comes down. The weight of the descending car helps to pull the ascending car up. This means the motor doesn't have to do all the heavy lifting. It mostly just has to deal with the difference in weight between the two cars and a little bit of friction. Even in systems that don't have two opposing cars like a gondola lift, the principle of balance is still important. The weight of all the cabins going down one side helps to balance the weight going up the other side. This makes the whole system much more energy efficient than a fleet of buses driving up and down the same hill, each with its own heavy engine. The cable car system puts all the power in one place and uses gravity as a helper, not an enemy. For a cable car to work properly, the cable itself has to be just right, not too tight and not too loose. This is called cable tension, and managing it is one of the most critical parts of the whole operation. If the cable were too loose, it would sag too much between the support towers. That could cause a bumpy, jerky ride, and, in the worst case, the cable could even slip off the wheels that guide it. On the other hand, if the cable were too tight, it would put strain on the towers, bull wheels, and the cable itself, which could lead to damage. So, how do engineers keep the tension perfect? Well, they use a clever system, often involving a giant counterweight. At one of the stations, the big return bull wheel isn't bolted firmly to the ground. Instead, it's mounted on a movable carriage, sort of like a cart on a short track. This carriage is attached to an enormous block of concrete, a counterweight weighing many tons. This massive weight is always pulling on the carriage, which in turn is always pulling on the bull wheel, which is always pulling on the main cable loop. This system automatically keeps the cable at just the right tension. This counterweight system is brilliant because it's self-regulating. As the sun heats the steel cable, it expands and gets longer, but the counterweight just sinks lower, pulling out that slack and keeping the tension constant. It's a simple, gravity-powered solution to a really complex engineering problem, working 24/7 without any computers. When you're dangling high above the ground or climbing a steep hill, you definitely want to know you're safe, right? That's why cable car systems are designed with multiple layers of safety features. The first line of defense is the brakes. And there isn't just one set, there are several, each ready to take over if another fails. There are service brakes for normal stopping and starting. Then you have the emergency brakes. These are powerful, fail-safe systems designed to stop everything quickly if something goes wrong, like if the power goes out or a sensor detects a problem. These brakes are often held open by hydraulic or electric power, which means if the power fails, they automatically slam shut. This fail-safe design is a core principle of engineering safety, but what if a car's grip were to fail on a steep track? There are brakes for that too. Funiculars and streetcars often have track brakes, powerful wedges that can be driven into the track using immense friction to bring the car to a halt. Beyond the brakes, the entire system is monitored by an army of sensors and human operators. They're watching cable tension, wind speed, motor temperature, and the position of every car. If any reading goes outside normal range, alarms sound, and the system can be shut down automatically. There are also backup generators to provide power in an outage and evacuation procedures that are practiced regularly. Every part of a cable car's design has one primary goal: to make your journey not just breathtaking, but incredibly safe. Cable cars are so much more than just a clever way to get up a hill. They're powerful tools that can transform cities and even our relationship with nature. In urban areas with challenging geography, think about the steep hillsides of Medellin, Colombia, or La Paz, Bolivia. Cable cars have become a real form of mass transit. They connect isolated, low-income communities on the hills with the city center, giving residents access to jobs, schools, and healthcare. They literally and figuratively lift communities up. In the mountains, cable cars are the lifeblood of tourism and recreation. They make majestic remote wilderness accessible to more people, not just expert mountaineers. A family can ride a gondola to a mountain peak for a picnic with a panoramic view, or a photographer can get to the perfect vantage point without a tough climb. They allow us to experience the grandeur of nature in a low-impact way, helping us appreciate our planet's beautiful and fragile environments. And let's talk about their environmental footprint. Compared to building a winding road up a mountainside, a cable car line is a gentle touch on the landscape. Because they are usually powered by electricity from a central motor, they produce zero emissions on site. If that electricity comes from renewable sources, the entire system can be incredibly eco-friendly. Ultimately, cable cars are connectors. They connect point A to point B. They connect people to nature. They connect communities to opportunities, and they connect us to a sense of wonder. Whether it's the charming clang of a historic streetcar, the the silent glide of a gondola over a forest canopy, or the thrilling ascent of an aerial tram up a sheer rock face, these systems offer a unique perspective on our world. They're a testament to the simple, brilliant idea that sometimes the best way forward is to go up. Consider it.